Good afternoon, everyone. I'm Matt Boyle. As you've already heard ad nauseum, now I was working with the Stevenson Challenge over the summer. My background is I'm an engineer. I got out when I was good enough to get out and smart enough to get out and started running a company. We grew Sevcon, which was a US public company, to 60 million in revenues towards the tail end of 2016, and were bought by Borg Warner for $200 million in September 17. Unfortunately, I think, even now, I think that my shareholders, if they knew what we know now, would have held on to it. I'm going to talk to you specifically, the disco lighting now. I'm going to talk to you specifically about Stevenson, but I have some caveats. They're not all vein-induced, but a fair amount of them are. First of all, I'd like to thank Alan and Gary and Paul for inviting me here today. It's really kind of you. Stevenson has been a fairly substantial task over the last several months, but it's not finished. Number one, it's not finished because it might not be called Stevenson in the end. All right, and secondly, you can put away all your notebooks because my presentation has been denuded with any numbers. So any forecasts of spend have been taken out of here, and now half the audience are leaving. But let me take you back a year. In the last year at BW, Borg Warner, we were working on low to high power drives for automotive, and I'll lead you down the story as to why we got there. Hope that's your battery and not mine. Oops, power electronics required. Yeah, so we were working on drives that were in the kind of 5 kilowatt to 300 kilowatt range, and those were across automotive applications, but not only. We were working on ASIL-D, and ASIL-D required us essentially to rip up all of our developments at the kind of 300 kilowatt range and start again. That was something that Pete Barris, whenever he came to see me, was my Chief Technology Officer, came to see me and said, "Matt, you know the work we've been doing over the last 5 years, we need to put it in the bin." You can imagine how that went down. Our drives, though, were not only focused, we now have power, we're not only focused on automotive. They were general applications. They were building blocks. And that's one of the things that as we were developing Stevenson, we were focusing on for the government, that this technology underpins an enormous amount of activity. In Sevcon, we're doing things like ship stabilizers to standby gensets. We were doing the Renault Twizy, which you see here, all the way through to the big truck at the end. We're doing Formula E to pontoon boats. Essentially, it was all transport. But you get the message. You know, the power electronics was ubiquitous. With that breadth, though, came with it a demand, a requirement for a clear mission, because the requirements of the Renault Twizy were somewhat different from the requirements of the MAN truck. All of our customers a year ago were focused on these three areas. And I don't think it comes as a surprise to anybody in this room that legislation was the major driver for them. But when you get into automotive, I think everybody here would agree that if you start talking about cost going up, OEMs start showing you the door. So cost was also a driver. And then last but by no means least, performance. And performance was kind of interesting because it flew in the face, at least in what we were doing, it flew in the face of the cost issue. This is Tony Harper's slide from last year. Those of you who were here last year, and those of you who have got a copy of the slide, know that there used to be a box in that corner which I spent about half an hour this morning painting out. This slide, the summary for Stevenson, is almost exactly what we took to government in September of this year. Almost exactly. And that tells me something, that the consistent message, the consistency of it, drives the true nature of it, because it wasn't difficult to make the leap from this set of criteria to asking government for a great deal of money out of ISCF Wave 3. And it was the start of the journey. So going back to, you recall the three bubbles and PEMD at the centre of it all, it was the first time in writing the Stevenson Challenge, the first time that cross-sectoral evidence was gathered and disseminated around the group. And that took us to all of these places. It took us to energy, automotive, aerospace, rail, con-ag, marine, and industrial applications. The expertise around the room when we were writing the challenge represented all of those locations. It was a fairly broad church. It is almost identical to the Borg-Warner drives business strategy a year ago. And I would suggest that the drivers are still the same. So sorry, Ven, this one survived. What we said to government is we think we can generate an extra 5 billion of GVA across power electronics, machines and drives. And you've heard some numbers today. Alan threw out some numbers about the size of the market opportunity that there is. When you look at across the 7 sectors, you can imagine that grows quite substantially. And I'll come back to that in a minute. But essentially what we're looking at, replacing ICE. Today we make 2.5 million engines in the UK. We can see the writing on the wall for those 2.5 million engines, or a substantial proportion of them. So replacing that with jobs and with technology to increase, not reduce the GVA, was one of the things that we wanted to do. We talked, and I will return to the topic, it's a long-term programme. Stevenson at the moment is 5 years. It's the start of a journey. It has to be sustainable, and it will be sustainable. Because of the nature of the market failure, it will be sustainable way beyond the end of the Stevenson Challenge. It covered 2 of the grand challenges. So it covered clean growth and future mobility. Whoopee, but as a byproduct, really, of the fact that it's power electronics, therefore it is green. Talk about nuclear energy, we can derive that if you want, but it is cleaner than internal combustion. And the future of mobility, we've heard it all. It's far easier to control a vehicle controlled by power electronics, machines and drives, than it is an internal combustion engine. Try telling that to Nissan. We've heard it, Paul mentioned it earlier on. The real raison d'etre for Stevenson is to develop the supply chain. It's disparate, it's fragmented. It didn't surprise me, any of the numbers that were thrown up in the couple of hundred people in the kind of tier 1 to tier N universe. But they don't talk to one another. They repeat the same solutions. It's an enormous waste of energy. And being a Scot, I hate that, because it's an extremely large waste of money. And then, last but by no means least, in what I wanted to have for Stevenson, it's the skills issue. And I'll come back to the skills issue in a minute. And then James Widmer, who was one of the, James actually and Bill, James, I see Will at the back there, James and Bill Drury, James Widmer and Bill Drury were very, very interested in the academic leadership. We truly have world-beating academia in this country in these areas, but we don't invest in them. So we were looking at trying to justify investment in a room in Newcastle about 9 months ago now, against an expression of interest which had generated an enormous amount of support. In the top right-hand corner, there were over 130 organisations who said, yeah, if you do it, we'll come. Their revenues were over 600 billion, household names there. So large cross-sectoral and large organisational support from around the country. But it really tried to address the legislative agenda of Her Majesty's government and governments around the world. You know, remember that what we're hoping to do here is build a supply chain not only for the UK, but for the world. So when we talked to and analysed all of the legislative agendas around the world, eliminating diesel rolling stock in rail by 2040, have you any idea how big a challenge that is? 80% reduction in carbon emission by 2050. Impossible without power electronics machines and drives. So, there was a fair amount of analysis done as to how we could get this off the ground quickly, and we decided that we had to focus, initially anyway, on the early adopters. And the early adopters happened to be automotive. So we identified the market failure as a lack of investment, both in skills, processes, collaboration, incubation. There are a number of businesses around the country are 5 to 10 people and have really struggled to make that 20. So helping those. A McKinsey report when I was running SevCon. The board commissioned a McKinsey report because they didn't believe that I needed to double the size of the engineering department. McKinsey came along after 9 months of analysis. And what they were asked to do was identify the area that the business should focus on going forward. And the report in the end, and I think I've still got a copy, said all of them. Do not rule out any application or any market sector because they are equally going to require power electronics and drives in the future. Which didn't help me at all. I mean, I doubled the size of the engineering department, but focus, going back to what it said, mission focus was on automotive. The reason we're focused on automotive at this point, and I'll come back to it in a second, is it is an early adopter. And it has the processes around it to make sure it doesn't screw up further down the line, despite putting dodgy code in informatics systems. If it was the Microsoft system, I'm going to see you after this. We are behind in some areas, but we're truly ahead in a great many. And it's about creating a supply chain that accentuates the positives and addresses the negatives. And our advantage in the UK, I can name some names, but we all know who we're talking about, do a very good job of superlative engineering into cars. You know, I used to run the controls business of a diesel engine genset. I used to run Alstom's genset business. And there's a whole different ball game when you put 4 wheels on it and you have it running around on a road. The other thing we need to do is get adoption swiftly. So in our negative camp, I think we've got cost and we've got market volume. Market volumes are a whole lot higher elsewhere. But on the positive, our auto sector and you lot. This is why we wanted to focus on automotive. all of the forecasts told us that the growth over the next 6-7 years was mostly going to come out of automotive. Now, because these are my numbers and nobody else's, I can tell you that the compound annual growth rates there are substantial double digits. Because, see backup slides for supporting data? Were my slides. This addressed, the other thing that's addressed is why now? Because people wander around saying, well, you know, we're too late. The Japanese are going to do it, or the Koreans are going to do it, or the Americans are going to do it. Well, that's not true. Because nowhere in the world does the sort of infrastructure that we have here today, ecosystem we have here today, exist to excel in these areas. If they did, I wouldn't be standing here. I would be off with them. The one thing we do have to address is skills. As I said earlier on, Stephenson's a journey. We've only just started. Stephenson is the core raison d'etre of Stephenson is to develop the supply chain. And that is not going to be done overnight. Some of the work we're doing quickly, I'll come on to in a second. But it's a long-term program. It's 5 years, at the moment it's a 5-year program, but it is not going to be solved in 12 to 18 months. I sat in more boardrooms than I care to mention and talked a lot about cross-sectoral advantages. And when I say that, ConAg can learn from automotive. Aerospace can teach automotive. Connecting those dots is something that nobody does and everybody should. If you don't, it's an enormous waste of money. We have committed some timescales which I'm no doubt will be flexible. He's nodding his head, which is a good result. But they address some of the issues that we all know exist: the skill shortages, the complexity of the engineering. Going back to the putting power electronics on something that has rubber tires and bounces up and down is no mean feat. But working together, I am absolutely certain we can address the skills issues. The complexity of the engineering challenges we can resolve, and we can create a truly world-beating supply chain. Ven would identify with this slide. So we're focused on being cross-sectoral. Everything from materials, so gallium nitride, silicon carbide, yep, all the way through to neodymium, hopefully at Wilton. All the way through from the raw material to the final product and beyond. Building a supply chain, not only to support automotive, but it has to be developed to support all of the sectors. Prototyping and scale-up is an extremely important thing for us to do. And prototyping and scale-up is the one thing that when you're an SME, because officially I was for a very long time, it's very, very difficult to get involved in. Because you're too small to be somebody an OEM would take seriously, and you're just constantly stuck in that catch-22. And then last but by no means least, the whole investment in our skills and requirements for more engineers. One of the things that I said a few months ago now is, as part of Stephenson, because of this, or the lack of this, I put £600 million into the Polish economy over a 20-year period. And he was making, I would suggest, somewhere in the region of 20% margin. That's a chunk of change. We need to stop doing that. We need to do that here. At the moment, and it will change, I've absolutely no doubt, and Ven's beginning to squirm in his seat, so I'll quickly pass on. But we're looking at quick start. So projects that can start quickly. Partnership between industry and academia. We don't do it well enough in this country, never have, but really should. Some of our facilities now, I stay not far from a world exemplar at Newcastle, and I can tell you that there's been no real investment there for 10 years. And that's scandalous, because it won't attract the people from all across the world who we want to and need to attract in order to develop the supply chain faster. In industry, gives them access to the leading academics. We try and get these intractable problems, and there are some, I can tell you, get them resolved and help them grow. And growth in the supply chain is going to be an extremely important KPI. You won't get out of a room talking to me without me bringing this up. I kid you not, there isn't a week goes by where I'm not asked, can you find me some engineers? And they're not UK resident. These people are all direct foreign investment. They want to come here, they want to set up here, they want to develop here, which is great, but it would go somewhere else for manufacture. Biggest threat to power electronics, machines and drives across the country is the lack of skilled people. There aren't enough of them, and that is at all levels in the supply chain. But it is a good time to be an engineer. The number of 31-year-olds earning 70 grand a year, I know, I lost count of. It's a very good time to be an engineer. So, in summary then, Stevenson, or whatever we're going to call it in the end, however much money it's going to spend, and we don't know that either. How much help it's going to get from API, APC, ATI, etc., 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 don't know yet. But it's all going to be focused on power electronics, machines and drives. It's addressing those three areas of concern for our customers, and it's going to be cross-sectoral. Those are givens. Thank you very much.